Okay. So yesterday we were talking about standard notation. Let's take a look at where we were. Or scientific notation. So scientific notation is a way to write really big or really small numbers. All right. This is the format and the rules of writing scientific notation. You have two factors. We're multiplying two factors together. That multiplication symbol is an X. The first factor is always like our numbers. We have one digit. It's either 1 through 9, one digit in front of the decimal, and then either no digits after or any number of digits after. Okay? The second factor is always 10 to some power. That power depends on the size of your standard form number. All right, and we are going to work today with going between standard form and scientific notation. What I do not want you guys doing, all your eyes over here please, because I want to be very clear with this. What I do not want you guys doing is connecting the sign of your power to whether you're going left or right with a decimal. I do not want you doing that. The moment you do that is the moment things get confusing because, well, which way do I go if I'm going from standard to scientific, scientific to standard? Like, that is going to get confusing. So you're going to hear me say a lot, what size is the standard form number? And that's the concept, that's the question I'm going to be asking all the time. What size is the standard form number? Because that's what goes with the power, with the sign of the power. Do you guys understand? So that's what I want you keeping in your head over and over. Because if you start to think of left and right, of which way you're moving your decimal, you're going to get confused. Okay? So size of standard form number is what determines if I have a negative power or a positive power, okay? And we started that conversation yesterday. So if our standard form is big, anything bigger than 10, we have a positive power on our 10 in standard form, or in scientific notation. So I'm just going to adjust this for a second. In scientific, God bless you, notation. So I'm just going to add that phrase there. So if standard form is really big, our scientific notation number is going to have a positive power on the 10. So really big means anything bigger than 10. Because as Colin asked yesterday, what happens if our standard form number is already like 3.56 or something? Well, that doesn't apply. I don't need to write that in scientific notation. It's not really, really big or really small. I don't need to write that in scientific notation. Scientific notation is when we have something like in a cell, the size of, I'm totally making this up, but like the size of the nucleus of a cell might be 0.000000056 millimeters or something like that, right? That's a tiny number. And so instead of writing all of those zeros, we now can condense that into scientific notation, and it's a lot easier to see. Can you guys see where that would work? Okay. So, smaller standard form, which is what the one I just gave you as an example, that's any number between 0 and 1. So that's a decimal. It could be 0.5. We could write that in scientific notation. All right? Small number, anything between 0 and 1, our power on the 10 is negative in scientific notation. Are you cool with that just so far, that idea of what size standard form goes with which sign? Not what sign is our number. What sign is the power on our 10? All right, and remember, we always leave negative powers on our 10s for scientific notation. Okay. All right, so what I want to do right now, I'm just going to date today's notes only just so I know that I took them today. So today is the 13th. I'm just going to date it right there. We are going to change between standard form and scientific notation. So change standard form numbers into scientific notation. All right, I'm going to do a problem to the left with some directions to the right. So let's say, for example, I have 120 million. All right. First of all, I'm going to change the standard form number into the first factor. Okay, I'm just going to rewrite this. 120 million. For this to be our first factor, and written properly, where does the decimal need to be? Right now, our decimal's at the very end. So this is my current location for my decimal. For me to turn this number into our first factor, where does our decimal need to be? Valentina? Yes, it needs to be in between the 1 and the 2. Why, Valentina? Yes, that first digit, it needs to be a 1, 2, 3, 4, 5, 6, 7, 8, or 9. It needs to be a single digit, not a 0. All right, so I need the decimal to be there. Are you guys good with that so far? Okay. So now what I need to do is I need to figure out how many decimal places I move the decimal. So 1, 2, 3, 4, 5, 6, 7, 8. So step 3, I'm just going to write an 8 here so I don't forget what I did. So step 2 is determine how many decimal places I need to move the decimal for the first factor. Okay, so I moved it 8 places. So that number of places, that is our power on our 10. So that number of places that I move the decimal, that is our power on our 10. So number of places is the power on the 10. So if I start writing this, I have 1.2 times 10, and I'm going to write 8 here. But now what I need to do with my step 3, this is going to be my step 3. I need to determine the sign of the exponent on the 10. This is when I go to the format that I talked about here. This is when we look at our what size our standard form is. So size of standard form. Was our standard form really big or really small? Was our standard form, this 120 million, that right there is standard form. Is our standard form really big or really small? Colin? It's really big. So what does that tell us about the sign of our exponent? If our number, if that standard form is really big, Cameron? It's positive. Exponent, positive. So this is going to be a positive 8. We normally don't put a positive symbol there, but I want you to understand that makes it positive because it's really big. Yes. Why am I leaving out the 2? 1, 2, 3, 4, 5, 6, 7, 8. I don't understand. I left out the 2. I guess I don't understand what that means. I didn't leave out the 2. Why am I leaving the 2 off? I counted the number of places I had to move my decimal. So for me to change that, I'm glad you're asking these questions because I want to make sure I understand what's in your brains, which is awesome. I need to change that standard form number into my first factor. So I can't, the only digits I'm ever going to drop off of this standard form are zeros. I'm not dropping off any non-zero numbers, okay? So this is 120 million. It's not 100 million. It's 120 million. So I have to keep that 2 in there, all right? If I was rounding and I wanted to round to the closest million, put your hand down. If I wanted to round to the closest million would be 100 million. But I still have to move the decimal 8 places. So it's not dropping, I'm not dropping those digits off. I have to move the decimal in between the first and the second digit always. Because I need to have a non-zero digit in the first decimal place, which is in the ones place, and then any numbers after the decimal. Does that make sense? Awesome. AJ. I'm sorry, say that one more time. You're not. From 0, any number between 0 and 1 is a small number, a decimal. It's not a big number. I just said to you, I already said this. Anything that is bigger than 10 is considered a bigger number. Anything that is between 0 and 1, a decimal, is considered a small number. And I already said this with Cullen's example yesterday, and I just said this just now. Cullen asked me, well, how do I turn, I think, Cullen, you said something like 4.63 or something like that into scientific notation. We don't. Because those numbers aren't numbers that we need to change into scientific notation. Scientific notation is only used for numbers that are really big, or anything like I could turn 12 into scientific notation. I can turn 136 into scientific notation. Anything 1 to 9, I don't change them into scientific notation. There's no reason to. It would be like 1 times 10 to the 0 power. Do you see that? Because 10 to the 0 power is 1. You know what I mean? So we don't change numbers because there's no reason to be changing them. They're already in the format of that first factor. Do you understand? Okay. Yes. You're not having variables in these, and you're not going to have negative numbers in these. Your standard form is not going to be negative because these are measurements. And you're typically never having a negative measurement when it comes to, like, you may have lost money. You may, a company may lose $1 million, but that's not a negative number. That's just they've lost it. You know what I mean? So we're not going to have negative values here other than our exponents. All right, let's do another one. All right, so I want you to change 340,000 into scientific notation. All of you do that, please. So check with someone sitting by you, see if you guys got the same thing. I always want you doing that. All right, so someone tell me, where does my decimal need to go for me to change this into my first factor? Brendan? Excellent. How many places did I have to move that, Brendan? So 1, 2, 3, 4, 5. I do want to see that. I want to see you moving that. I'm just going to write a 5 here just so I remember. So write my number now in scientific notation, Brendan. Is that a positive 5 or negative 5? Why? So this is 34,000. 340,000 is a big number, right? So I'm going to say here positive because for right now, I want you writing that in your notes. Your homework, you don't have to, but as you're learning this, I need you to connect those. Positive because standard form, big. All right, let's do this one. I want you to change 0.000125 into scientific notation. All of you do that, please. So there are, after the decimal, there are 3 zeros. Just put your pencil down when you're finished. Check what people buy you. See if you guys got the same thing. Every day, every time we do an example, that's what I want you to do. Put your pencil down when you're done. Talk to people by you. See if you guys got the same thing. So Ava, Ada, and Patrick, talk to each other, please. Work with each other. Help each other out. When you're done, put your pencil down so I know you're finished. You're welcome, sweetheart. All right, so someone tell me, who wants to do this one for me? Matthew, go ahead. Excellent. How many of you guys agree with him? All right, make sure that exponent is high, that it doesn't look like it's a number. Why is that negative, Matthew? What is its? So the standard form is a small number. Yep, so the standard form is a small number. All right, let me give you a couple more of these to do, and then we're going to go in the other direction. All right, so I want you guys to change the following numbers. Into scientific notation. All right, so my first one is going to be 4,100. Get going on that one. I'll put a couple more up. So those 3, please. Again, when you're done, check with people by you. do want you to get in the habit of rewriting your given so you remember what you started with, or that you can see what you started with. All right, somebody do the first one for me. Sophia, put the chair down, please. We're not leaning back. Go ahead, Sophia. To where? So we have to move the decimal between the 4 and the 1. So that's 3 times. All right, go ahead and write that in scientific notation for me. Positive or negative? Why? Excellent. Our standard form is bigger. All right, somebody do number 2 for me. Go ahead, AJ. Excellent. Why is it negative? Excellent. All right, somebody do that last one for me. Amanda, go ahead. Excellent. Yeah, be careful with these long ones. Make sure that you get between each digit. You said 10, right? Y to the positive 10th power. Excellent. How many of you guys are cool with this? Not too bad, right? Okay, so now we're going to go in the other direction. We're going to go from scientific notation to standard form. The thought process is the same. I need you paying attention to the size of your the size and the sign of your power, so we can use that to change it back into standard form. Okay? All right. All right, so I want to talk about changing from scientific notation to standard form. All right. I want to explain to you why this works, okay? So if I have 10 to the 3rd power, if I write that out in using exponents, or I write 10 to the 3rd power, what does 10 to the 3rd power mean? Like if I threw 10 to the 3rd power at a calculator, what would I get? Molly? What would I get? Well, yeah, if I threw 10 to the 3rd in a calculator, what would I get? Sarah? 1,000. How many of you guys agree with that? Okay. If I throw 10 to the negative, well, if I change 10 to the negative 3rd into a positive power, what does that look like? So change that, use your power rule, and change that so I have a positive power. Ada? 1 over 10 to the 3rd. And if I write that now in standard form, what would I get if you multiplied that 10 to the 3rd out? 1 over 1,000. Are you guys cool with me so far? Okay. So if I have 3 times 10 to the 3rd, this is the same thing as 3 times 1,000. How many of you guys agree with that? All right. So this is going to end up being 3,000. Right? This is not what I just want you to understand why these powers work the way they do when we start in scientific notation. Okay? I just want you to understand this. If I have 3 times 10 to the negative 3rd, this is the same thing as 3 times 1 over 1,000. So this is 3 1,000ths. If I'm dividing by 1,000, don't I move my decimal 3 places to the left? How many of you guys agree with that? If I'm dividing a number by 1,000, aren't I just doing this? 1, 2, 3, and that's 0.003. How many of you guys would agree with that? Okay, so I need you guys to keep that in mind as we are changing between scientific notation and standard form. Okay, so this is kind of a side note for you guys to keep in your head. So let's say I had 2.1 times 10 to the 6th power. All right, so first of all, what you're going to do, all right, you're going to write down the first factor so you can move the decimal. So that's super easy. I'm just going to write down 2.1 here. The second thing you're going to do is you're going to look at the power on the 10. If it is positive, we need to change first factor to a bigger number for standard form. If the power is negative, we are changing your first factor into a smaller standard form number. Can't write. We're going to change first factor into a smaller standard form number. So we need to take a look at that power. And remember, the power is the number of places you're moving your decimal. So that power is the number of places you move the decimal. So that power is the number of places you move the decimal. So someone tell me, is my power on my 10 positive or negative? So I'm just going to make a note here. Is that power on my 10 a positive or a negative? Addison? That's a positive 6, right? So that means that I need to move my decimal 6 places. Which direction am I moving my decimal 6 places to make that first factor bigger? Addison? To the right. So 1, 2, 3, 4, 5, 6. And now anywhere that I have one of those little jumps, I fill it in with zeros. So the third step here is going to be move the decimal on the first factor. The number of times of the exponent. All right, so my final answer is going to be, I'm just going to rewrite this, 2, 1, and then 1, 2, 3, 4, 5 zeros. And then I'm going to put my commas in so they're proper commas. So remember, every 3 starting from right going to the left, every grouping of 3 gets a comma. Questions on this process before I give you another one to do? Does this make sense to you guys? Right? Okay. Who needs to see what's up there? All right, so the first thing you're doing is you're writing down that first factor. The second thing you're doing is looking at that exponent. You're looking to see what it is, because that's a number of places you're moving your decimal. If it's positive, you need to change your first factor into a bigger number, right? Because that means standard form is going to be a bigger number. Move your decimal to the right. If it is a negative power, that means you have to turn that first factor into a really small standard form, which means you have to move the decimal to the left in the other direction. Can you guys see why I'm attaching the sign of the power to bigger or smaller standard form numbers? Does that make sense to you guys? Awesome. All right, so I want you to change this number into standard form. I want you to change 8.68 times 10 to the negative 7th into standard form. When you're done, check with someone sitting by you, see what you got. Make sure you guys did it right. Remember, that power is not how many zeros you're putting on something. It's how many places you're moving your decimal. That's a common mistake that I see, is that people are like, oh, there's 7 places, that's a 7 on there. I've got to throw 7 zeros on there. No, that's how many places you're moving your decimal. So, somebody I need to rewrite this so I can kind of move it over. Somebody do this one for me. All right, Ada, you're up. Excellent. So we're making it smaller, right? So 1, 2, 3, 4, 5, 6, 7. I would highly advise that you make these little swoopy dudes bigger, not smaller. So you can see where you have a little swoopy. All right, because if you're making them like this, you're not going to see where you have to put a digit, are you? So be really clear about where your movements are. So Ada, I'm going to go ahead and put some zeros in here. So tell me what my final answer is in standard form. How many of them? Okay. Excellent. Questions? Okay, I'm going to give you a couple that I want you guys to change into standard form. Okay. So my first one is 7.1 times 10 to the 4th. I'll put the other ones up. All right, so there are 4 of them up there. Go ahead. All right, somebody do that first one for me. Patrick, go ahead, sweetie. How many places? 4. So 1, 2, 3, 4. Why am I going to the right 4? Excellent. All right, so I'm going to throw some zeros on there, and then tell me what my final answer is, Patrick. How many of you guys got 71,000? Nice. All right, somebody do the second one for me. Danny. Matthew, put it down. Okay. Y to the left. Yep, and we need to make our standard form small, right? So what is my final answer? Excellent. All right. How about 3? Sarah. Excellent. 1, 2, 3, 4, 5, 6. So let me just throw those on there. So how many zeros am I putting in there, Sarah? So tell me my new number. 1, 2, 3, 6, 4, 1. Excellent. All right, someone do that last one for me. Nico. Shh. All right. Excellent. Nice job, you guys. Pretty easy? Pretty cool? Awesome. You guys are good to go.